12th problem. If the angle measures of a triangle are x, y, z, x by 2 plus y by 2 plus z by 2 equal to dash. In the figure, P is the incenter and angle A equal to 80 degree. Find angle BPC. X by 2 plus y by 2 plus z by 2 equal to x plus y plus z by 2. Here x, y, z are the three angles of a triangle. Therefore, their sum is 180. Hence, this is equal to 180 by 2, or that is equal to 90 degree. Let angle A equal to x, angle B equal to y, and angle C equal to z. Here, angle A equal to 80 degree. Therefore, x by 2 equal to 40 degree. The first part of the problem, we have obtained that x by 2 plus y by 2 plus z by 2 equal to 90 degree. But x by 2 equal to 40 degree. Therefore, we can write 40 plus y by 2 plus z by 2 equal to 90, or y by 2 plus z by 2 equal to 90 minus 40, or 50 degree. So, we have got that y by 2 plus z by 2 equal to 50 degree. Now, let us look at the figure once again. We have taken angle A as x, angle B as y, and angle C as z. Now, PBC is a triangle. Therefore, the sum of the three angles is 180 degree. That is angle BPC plus angle PBC plus angle PCB equal to 180 degree. Therefore, angle BPC equal to 180 minus angle PBC plus angle PCB. Now, P is the incenter. Therefore, BP is the bisector of angle B. That is angle BBC equal to y by 2. Similarly, angle PCB equal to z by 2. So, we can write angle BPC equal to 180 minus y by 2 plus z by 2. But we have already got that y by 2 plus z by 2 equal to 50. So, we can write 180 minus 50, and that is equal to 130 degree. 13th problem. While writing the equation to construct a rectangle of a specified perimeter and area, perimeter was wrongly written as 46 instead of 64. One side of the rectangle was then computed as 20 meters. What is the length of the other side? What is the area of the rectangle? Find the sides of the rectangle in the original problem. When the perimeter was taken as 46, one side is given as 20 meter. We know perimeter equal to 2 times length plus breadth. Here perimeter is 46, so 46 equal to 2 times length plus breadth. Hence, length plus breadth equal to 46 by 2, or 23. Given that one side is 20 meter and the sum is 23, so the other side should be 3 meters. Now, the area of the rectangle is length into breadth, that is 20 into 3, or 60 meters square. Now, we have to find the sides of the rectangle in the original problem. Here, we are considering only rectangles of specified perimeter and area, and we have got that the area is 60 meters square and the correct perimeter is 64. That is, for our rectangle, the perimeter is 64 and area is 60, and we have to find the sides. Now, given that perimeter equal to 64, we know perimeter means 2 times length into breadth. So, length plus breadth is 32. Let us take the length as x, then the breadth is 32 minus x, because their sum is 32. Now, given that area is equal to 60, and we know area of a rectangle is length into breadth, therefore x into 32 minus x equal to 60. Multiplying, we will get 32x minus x square equal to 60. Now, let me multiply each and every term by minus 1. So, I will get minus 32x plus x square equal to minus 60. Now, let me write the term containing x square at first. So I can write it as x square minus 32x equal to minus 60. Now let me use completing square method. Here the coefficient of x is minus 32. Let me take only 32 because when we take the square it becomes positive always. So the half is 16 and the square is 16 square. So let me add 16 square on both sides to make it a perfect square. So we get x square minus 32x plus 16 square equal to minus 60 plus 16 square. Now the left hand side is a perfect square and that is x minus 16 whole square. And on the right hand side we can write minus 60 plus 256. And what is minus 60 plus 256? That is 196. Now taking square root on both sides, we can write x minus 16 equal to square root of 196 or plus or minus 14. Now we can make two equations, x minus 16 equal to 14 or x minus 16 equal to minus 14. From the first one we can write x equal to 14 plus 16 or x equal to 30. From the second one we can write x equal to minus 14 plus 16 or x equal to 2. So we got two values for length because we have taken x as the length. When the length is 30, breadth is 32 minus x or 2 meters. When the length is 2, breadth is again 32 minus x, that is 30 meters. So whatever it be, the two sides are 30 meters and 2 meters. 14th problem. In the figure, angle B equal to 90 degree, AB equal to C, BC equal to A, AC equal to B. Angle A plus angle C equal to dash. Prove that sin A equal to cos C. If sin 24 equal to cos x, find x. Let us look at the figure. The sum of the three angles of a triangle is 180. And here angle B equal to 90 degree. Therefore angle A plus angle C equal to 90 degree. Now we have to prove that sin A equal to cos C. Let us take sin A at first. What is sin? Opposite side by hypotenuse. Which is the opposite side of angle A here? That is A. And hypotenuse B. Therefore sin A equal to A by B. Now we know cos means adjacent side by hypotenuse, which is the adjacent side of angle C here, A, and hypotenuse B. So cos C equal to A by B. That is sin A equal to A by B and cos C also equal to A by B. Therefore we can say sin A equal to cos C. Now the third part, we have seen sin A equal to cos C. So if sin 24 equal to cos x, angle A equal to 24 and angle C equal to x. And we have already seen that angle A plus angle C equal to 90 degree. Therefore 24 plus x equal to 90, x equal to 90 minus 24 or 66 degree. 15th problem. In the figure, angle Q equal to angle R equal to 30 degree, PQ equal to 6 centimeters. What is the length of PR? Find the length of QR. Draw triangle PQR. Here, angle Q equal to angle R. Therefore, PQR is an isosceles triangle. Hence, the sides opposite to these angles are also equal. That is, PR equal to PQ and that is equal to 6 centimeter. Now we have to find the length of QR. For that, let me draw a perpendicular from P to the side QR. Let it be PS. Then angle QPS equal to 60 degree because PS is the perpendicular. Now let me find QS, which is the adjacent side of angle Q, and PQ is the hypotenuse. So let me take cos 30, which is equal to QS by PQ. Now the value of cos 30 is root 3 by 2, and given that PQ equal to 6, replacing the values we will get root 3 by 2 equal to QS by 6. Now taking 6 on the other side, we will get Qx equal to 6 into root 3 by 2. 3 2's are 6, cancelling we will get Qs equal to root 3 into 3 or 3 root 3. Here triangle PRS and PQS are equal because we know PR and PQ are equal. PS is the common side and angle SP are also equal to 60 degree. Therefore, RS is also equal to 3 root 3. Another way we can say the perpendicular from P to the side QR bisect QR because it's an isosceles triangle. Whatever it be, RS is also equal to 3 root 3. Hence, QR equal to QS plus RS, that is 3 root 3 plus 3 root 3, which is equal to 6 root 3 centimeters. Now we have to draw triangle PQR. Let us draw PQ equal to 6 cm at first. Now take 120 degree at P. Now take 6 cm on this line and mark PR. Join Q to R to get the required triangle. 16th problem. ABC is an equilateral triangle. Coordinates of B are 1, 4 and that of D are 4, 4. D is the midpoint of BC. What are the coordinates of C? Write the coordinates of A. Given that the coordinates of B are 1, 4 and that of D are 4, 4, therefore the distance from B to D is 3. Also given that D is the midpoint of BC, therefore the distance from D to C is also 3. Hence the coordinates of C are 7, 4. Now ABC is an equilateral triangle, therefore angle B equal to 60 degree. Since D is the midpoint of BC, AD is perpendicular to BC and hence angle D equal to 90 degree and therefore angle BAD equal to 30 degree. Now the ratio of the sides of triangle BAD is 1 is to root 3 is to 2. That is BD is to AD is to AB equal to 1 is to root 3 is to 2. But BD equal to 3. Therefore AD equal to 3 root 3. Now the x-coordinate of A is the x-coordinate of D because A and D are on the same line which is parallel to y-axis. Therefore x-coordinate of A equal to 4. Now what is meant by y-coordinate of A? That is actually the distance from x-axis to A. Now the distance from x-axis to A can be written as the distance from x-axis to D plus the distance from D to A. The distance from x-axis to D is actually the y-coordinate of D, so it is 4, and the distance from D to A is AD, that is 3 root 3. Therefore, y coordinate of A is 4 plus 3 root 3. Hence, the coordinates of A are 4, 4 plus 3 root 3. 17th problem. Surface area of a solid sphere is 400 pi square centimeters. What is the radius of the sphere? How many small spheres of radius 1 centimeter can be made by melting and recasting the given sphere? How many small spheres of radius 1 centimeter can be made by melting and recasting a solid hemisphere of total surface area 300 pi square centimeters? Given that surface area of sphere is 400 pi. Now the surface area of a sphere is 4 pi r square. Therefore, we can write 4 pi r square equal to 400 pi. Therefore, r square is equal to 400 pi divided by 4 pi. That's equal to 100. Hence, r equal to 10. That is, the radius of the sphere is 10 centimeter. Now the second part, how many small spheres of radius 1 centimeter can be made by melting and recasting the given sphere? Number of spheres equal to volume of large sphere by volume of small spheres. And the volume of a sphere is 4 by 3 pi r cube. Let us take the radius of this large sphere as capital R and radius of the small sphere as small r. Then we can write number of spheres equal to 4 by 3 pi capital R cube by 4 by 3 pi small r cube. Now you can see on both numerator and denominator 4 by 3 pi is common. So we can cancel it and we can write this equal to capital R cube by small r cube. Now capital R, that is the radius of the largest sphere, is 10 centimeter, and small r, that is the radius of the small sphere, is 1 centimeter. So this can be written as 10 cube by 1 cube. Now 10 cube is 1000 and 1 cube is 1. So this is 1000 by 1, that is equal to 1000. That means number of spheres equal to 1000. Now the third part, how many small spheres of radius 1 centimeter can be made by melting and recasting a solid hemisphere of total surface area 305 square centimeters. Let us find the radius of the hemisphere at first. Given that surface area of the hemisphere is 300 pi, and we know that surface area of a hemisphere is 3 pi r square. So we can write 3 pi r square equal to 300 pi. So r square is equal to 300 pi by 3 pi, or that is equal to 100. So the radius of the hemisphere is 10 centimeters. Now we have to find number of spheres, and number of spheres equal to volume of hemisphere by volume of small sphere. And volume of a hemisphere is 2 by 3 pi r cube. Let us take the radius of a hemisphere as capital R and radius of the sphere as small r. Then we can write this as 2 by 3 pi r cube by 4 by 3 pi r cube. Now on both numerator and denominator we can cancel pi and 3, and 2 2's are 4. Simplifying, we will get capital R cube by 2 r cube. Now the radius of the hemisphere, that is capital R, equal to 10 and radius of the sphere equal to 1. So replacing the values, we can write 10 cube by 2 into 1 cube, that is 1000 by 2 or 500. So number of spheres that can be made is equal to 500. 18th problem. In the figure, coordinates of the point B are 4, 4. The circle touches the right angle triangle at the points P, Q, R. Write the coordinates of A. What are the coordinates of R? What is the length of OP? Find the coordinates of P. Given that the coordinates of B are 4, 4, Therefore, OA equal to 4 and AB equal to 4. Hence, the coordinate of A are 4, 0. Triangle OAB is an isosceles triangle. Since OR is the tangent and AR is the diameter, AR is perpendicular to OB. Therefore, AR bisect OB. That is, R is the midpoint of OB. Here O is 0, 0 and B is 4, 4. Therefore, the midpoint of OB is 0 plus 4 by 2, 0 plus 4 by 2. That is, the coordinates of R are 2, 2. Now the third part, we have to find the length of OP. We know OP and OR are equal because they are tangent from the point O. Therefore, OP equal to OR. And OR is the distance from origin to the point R, which is 2, 2. Therefore, OR equal to root of 2 square plus 2 square. That is root of 4 plus 4 or root 8. And root 8 can be written as 2 root 2. Therefore, OP equal to 2 root 2. Now we have to find the coordinates of P. OP is 2 root 2. Therefore, x coordinate of P is 2 root 2. And since it is on the x-axis, y coordinate is 0. Therefore, the coordinates of P are 2 root 2, 0. 19th problem. The inradius of a triangle is 2.5 centimeters and two of its angles are 60 degree and 50 degree. Draw the triangle. In a circle, the angle between the radii through 2 points and the angle between the tangents at these points are supplementary. Therefore, instead of taking 60 degree, we can take 120 degree at the center. Similarly, for 50 degree, we can take 130 degree at the center. First of all, let us draw a circle of radius 2.5 centimeters. Draw a radius. Take 120 degree at the center and draw another radius. Now take 130 degree at the center and draw one more radius. Now at the end of each radius we have to draw tangents. Draw tangent at the end of the first radius. Extend the tangent. Draw tangent at the end of the second radius. Extend the tangent so that it meet the other. Now draw tangent at the end of the third radius. Extend all the tangents so that we get a triangle. Now we got a triangle ABC, which is the required triangle. 20th problem. Radii of two spheres are in the ratio 2:3. What is the ratio of the surface areas? Find the ratio of the volumes. Let the radii be R1 and R2. Then R1 is to R2 equal to 2:3. Let us find the ratio of the surface areas. That is equal to 4 pi R1 square is to 4 pi R2 square. 4 pi can be cancelled and we can write R1 square is to R2 square. That is 2 square is to 3 square, and that is equal to 4 is to 9. Therefore, the ratio of the surface areas is 4:9. Now the ratio of volumes is equal to 4 by 3 pi r1 cube is to 4 by 3 pi r2 cube. 4 by 3 pi can be cancelled and we will get r1 cube is to r2 cube. That is 2 cube is to 3 cube. And that's equal to 8 is to 27. Therefore, the ratio of the volumes is 8 is to 27. 21. Write the sequence of multiples of 4. Write the algebraic expression to state that the product of two consecutive terms of this sequence is 320. What number should be added to the product of any two consecutive terms of this sequence to get a perfect square? The multiples of 4 are 4, 8, 12, etc. Therefore, the sequence of multiples of 4 equal to 4, 8, 12, etc. Now, to get any term of this sequence, we have to add 4 to the previous term. So, if we take any one term as x, then the next term will be x plus 4. Now we have to write an algebraic expression to state the product of any two consecutive terms of this sequence is 320. Here we have taken x and x plus 4 as the consecutive terms. So the product x into x plus 4 equal to 320. Now multiplying, we will get x square plus 4x equal to 320. Here the coefficient of x is 4, half of it is 2 and the square of it is 4. So we have to add 4 to make it a perfect square.